Hey guys, welcome back. We're starting our last unit, Intro to Trig, before the EOC, or the TM Ready, whatever you want to call it. It's coming up soon. So we're doing a little introduction to Trig, learning about the unit circle, degrees, radians, that kind of stuff. So to start off with, after we talk about circles, you haven't learned about them since geometry, which was a while ago for most of you. Equation of a circle can be written like this. Right, x minus h squared plus y minus k squared equals r squared, where hk represents the center of the circle and r is the radius. So we wanted to practice writing the equation of a circle with values to plug in, right? So the first one is we have the center at 2, -3. So we'd say x minus 2 squared, y plus 3 squared. And then the radius is 5, so 5 squared would be 25. Or in the next one, the center is at 0, 6, so we'll say x squared plus y minus 6 squared equals 6 squared, which is 36. Or in the last one, we have a center at 0, 0 and a radius of 1. So that'd be x squared plus y squared equals 1. Now this last equation is actually really important to mathematicians. So important they gave it a name, called it the unit circle, which was printed right here, this. So the unit circle is the circle with the equation x squared plus y squared equals 1. So it's centered at the origin. So this point in the middle is the point 0, 0. And it has a radius of 1. Okay, so that means if we go over to the edge of the circle, this would be the point at 1, 0. This would be the point at 0, 1. This would be the point at -1, 0. And this bottom point would be at 0, -1. Okay, so every time you go over one full unit to the circle, you hit a point on the circle, right? Because the radius is 1 here. So the distance from the center to the edge is 1 unit. All right? So that's true anywhere. Like if I went up to this point, that's still a distance of 1. But since I'm not going over and up 1, we wouldn't call that point 1, 1. We'd call it something else. We'll talk about that eventually. So we want to learn how to label all of this stuff on the unit circle. There's a lot of dots that are put in here that represent specific values that mathematicians care about because they show up quite a bit. So let's kick it off by talking about something that I think most people know about circles. They know how many degrees are in a circle. Hopefully you remember that as well. If you go all the way around the circle, that's 360 degrees. Okay, so mathematicians decided you had to have a starting place, so we always start on the right side. Okay, so you're always going to start here. So that point represents both 0 degrees and 360 degrees. It's the starting place, and then if you go around one full time, that would be 360. So logically, if we went around half the circle, if all the way around is 360, what would halfway around be? Hopefully you said 180. Okay. What if I went halfway to 180? What's half of 180? And where would that be? So this point would be at 90 degrees. And then what's halfway to 90? Well, notice exactly in the middle of this quadrant, there's a point right here. That would be 45 degrees. Okay, so every time that we go this halfway through a quadrant, or a fourth of the way around half the circle, or 1, 2, 3, an eighth of the way, had to count for a second, an eighth of the way around the whole circle. Every time I go 1/8 of the way around the circle, that's 45 degrees. Okay, so 45, and then 45 plus 45 is 90. 90 plus 45 gives us 135. If I add 45 to 135, we get 180. If I add 45 to 180, we get 225. If I add 45 again, we get 270. That'd be here. And then if I add 45 to 270, we get 315. And if we add 45 again, we get 360. Okay, so part of learning this is we're just basically learning our way, learning how to count around the circle. In this case, for the points we've labeled so far, we were counting by 45, right? 145, 245, 345, etc. My drink's empty. That's depressing. So notice we skipped a lot of points, right? So if the point here at 45 represents halfway to 90, then the other 2 points, you might guess, represent thirds of the way. So what's 1/3 of 90? It's 30. Okay, so every time I go this distance around the circle, that's 30 more degrees. So if I add 30 again, we get 60. If we add 30 again, going that same distance, we get 90. If I add 30 again, I get 120. And then 150. And then 180. 210. 240. 270. 300. 330. And 360. And boom, we've got all the degrees done. Okay? Which is kind of neat. So, moving on down here to this bottom question. It asks, what's a radian? And there's a good chance you've probably never heard the word radian before, but you've heard of something that sounds like the word radian. Trying to think of what I can use for this. You've heard the word radius, right? A radius is a distance from the edge of the circle to the center, right? This distance is the radius. I have something on the back of my paper that's driving me insane. Okay, sorry, we're back. So this is the radius, right? So what happens if you take... I'm going to pause this and look for like a piece of string. 1 second. Okay, I think I'm back. I found a thing to use. So what I'm going to do is I'm going to lay this piece of stuff. I'm going to measure out where the radius is. Okay, so the radius is about that long. I'm going to cut this at the radius. Okay, so now this piece of stuff is exactly the length of the radius, like so, or approximately, maybe a tad too long, close enough. Okay, perfect. So if I take the length of the radius and we start to wrap it around the circle, so starting at our starting point and trying to lay this as close as we can, like so. Notice we can fit one radius around the circle and it goes to about here, just below 60 degrees. Okay, I should probably color code this. Use a nice orange. Okay, so this distance is 1 radian. So a radian is a length of around the circle, like an arc, an angle measure, that's equivalent to 1 radian, 1 radius. Okay, so if I lay this again around the circle, like so, you can see that 2 radians takes us to about here. Okay, so that's 2 radians here. And then I'm going to do this one more time. I got starting at that 2 radian mark. Okay, something like this. Beautiful, beautiful. Okay, so right there, just below 180, that would be 3 radians. Okay, so how many radians do you think it takes us to get exactly to this dot? Maybe good guesses there. Hopefully you know it's slightly more than 3. Are there any numbers that you know of that are slightly more than 3 that mathematicians think are super rad? Hopefully you came up with pi, right? Pi. This is pi radians right here. We can fit pi radiuses around the circle. So this dot represents 180 degrees or pi radians, which is pretty neat. So if I went all the way around, if halfway is pi, what would all the way around be? Well, that'd be 2 pi. Okay, or 0 pi if you started counting there. So let's count all the little dots in terms of radians. Okay, so if halfway around is pi, what would 90 degrees be? Well, it's halfway to pi, right? So half of pi. Most mathematicians write that as pi divided by 2. Same thing as 1/2 pi, though. If I go halfway to 90, that's 45 degrees. That would be half of pi over 2, which is pi over 4. Okay, so every time that we count off one of these 45-degree marks, that's 1 pi over 4. So let's test how well we can count our pi over 4s. 1 pi over 4. 2 pi over 4, which reduces to pi over 2. This is 3 pi over 4 here. That doesn't reduce. Then we got 4 pi over 4, which reduces to be pi. And then 5 pi over 4. And then 6 pi over 4, which reduces to be 3 pi over 2. So 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4 is 2 pi. Okay, so every time we count off those 45-degree marks, that's another pi over 4 that we add to our list. And then let's go back and do the 30 degrees. Okay, so if 90 is pi over 2 and 30 is 1/3 of 90, and I could take 1/3 of pi over 2, which gives me pi over 6. I'm going to zoom in a little bit. I feel like that's really far out. Okay, so every time we count off one of these 30-degree marks, that's pi over 6. So we got 1 pi over 6. 60 degrees would be 2 pi over 6. 90 is 3 pi over 6, which reduces. We got 4 pi over 6. We're just counting, right? 5 pi over 6. Pi is 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6 is 3 pi over 2. 10 pi over 6, and 11 pi over 6. A few of these things reduced, and I just didn't write them down, right? So 2 pi over 6 is the same thing as 1 pi over 3. 4 pi over 6 is the same thing as 2 pi over 3. Down here at the bottom, 8 pi over 6 is 4 pi over 3. And 10 pi over 6 is 5 pi over 3. Okay, and then just for completeness, this question, what is a radian? It's an angle with an arc length equal to the radius. Okay. Cool. Alright, there's only one thing left to do up here, and it's probably the funnest part. And I'm torn between wanting to show you why and wanting to just speed this up and get you through it. I think I should show you why, though, because you're probably more likely to remember it if I explain why things work. So we labeled some of the points, right? Like I know this is 1, 0, that's 0, 1, that's negative 1, 0, that's 0, negative 1. There's a lot of other points that we want to label as well. The nice thing is that because of symmetry, if we can get the points in the first quadrant, these three, then we can just change the signs of those same numbers to get the other points because they're symmetric, right? The height of this point is the same as the height of this point, so those y values are the same. And it turns out that the distance here is the same as the distance here, so the x values are the same as well. The only difference is that in quadrant 2, all of the x values are negative. Okay, so how do we find these points? Well, turns out you can draw in a nice little right triangle here. And that right triangle has an angle down here at the bottom that is equivalent to the angle that we've labeled here. So like this point is at 30 degrees. So that means this angle down here is also 30 degrees, which would make the angle at the top up here 60 degrees. So we have a nice little 30, 60, 90 right triangle. In geometry, you should have learned that there are sides that go along with the 30, 60, 90. I'm going to write them up here. 30, 60, 90 has sides that are x, x root 3, and 2x in that order. So the side that's across from the 30 is our x, the side that's across from the 60 is our x root 3, and the side across from the 90 is our 2x. Okay. We know that the hypotenuse of this is equal to 1 because the hypotenuse of this right triangle is the radius. And this is the unit circle, and the radius is 1. Okay, so if this is 1, that represents our 2x side, which means that x has to be a half in this problem. So the side of the triangle that's across from the 30 degrees has to be a half. So the height here is 1/2. And then if I plug in a half here, the other side has to be 1/2 root 3, or root 3 over 2. Which means that the point is going over root 3 over 2 and up 1/2. So at 30 degrees, the point is root 3 over 2, 1/2. Okay. We could do the exact same thing and draw in another triangle here for the 45-degree one, except you wouldn't get a 30, 60, 90. You would get a 45, 45, 90, which is another one of those special right triangles that you learned about in geometry. The sides there are x, x, and x root 2, where the x root 2 side is the hypotenuse, the one across from the 90. And again, we know that the hypotenuse of a triangle that's drawn there is going to be 1, which means the other sides are going to be root 2 over 2. So the x and y values for this point are the same, and they're both root 2 over 2. Okay, got some good news. We're almost done with all the thinking that this requires. For this last one, if you drop in the height here, and you go and find the triangle, it's going to be the exact same triangle this was, just tilted in a different angle, right? Instead of having the 30 at the bottom, now we have 30 at the top, and the 60s down here, which means we've just taken the x and y coordinates and flipped them. So this point is going to be the same as this one, just backwards. Something like that. Okay. So, like I said, because all of the points on the unit circle are symmetric, if you can find these first three, or if you can memorize these first three, you don't have to find them every single time. They're not hard numbers to memorize. There's really only 3 choices. If you can get those first 3, then you're just reflecting across to find the others. Like I know that this point lines up with this one, so they have the same values. It's still root 3 over 2 and a half. But this point is in quadrant 2, and you can see the x values there are negative. So you put a negative in front. Right, the 135 goes with the 45. Those are both root 2 over 2, except the x value is negative in the front. And then at 120, it's still a half root 3 over 2, but the x value is negative. Okay. Moving down to the bottom, I know that these 2 points have the same values, right? So 210 is going to be the same point as this, root 3 over 2, comma, a half. But we're in quadrant 3 now, and the x values are negative and the y values are negative, so they're both negative here. And then root 2 over 2, root 2 over 2, they're both negative. And then 1/2 root 3 over 2, and they're both negative. Going straight across, the point at 300 is going to be the same as the point at 240, except in this quadrant, only the y values are negative. Okay, so you're just filling in those same numbers over and over again until you're done. Okay, this is everything, right? This is our full unit circle. I know my face is kind of in the way. All right, so the idea is, in order to be successful with trig in Algebra 2, you need to be able to picture what these values are. Be able to draw this out and count it out over and over again. Okay, and the idea is, if you were in school, we'd practice this a lot in class. We would take little quizzes where you have 5 minutes to try to fill this in from memory. So it'd be great if you could practice this a few times on your own. You can print out these notes again to have like a blank one to work with, and to see if you can count your way around, right? Using the same logic we did. Figure out that 360 degrees, cut in half is 180, cut in half is 90, cut in half is 45. Count by your 45s around the circle. A third of 90 is 30. Count by 30s around the circle. That's your degrees. We also know that halfway around the circle is pi radians. So half of pi is pi over 2. Half of that's pi over 4. Count by your pi over 4s. A third of pi over 2 is pi over 6. So you count by your pi over 6s. And that's all the radians. And then finally, list out your points. Now the easy way to remember the points is there's only 3 numbers here, right? You have, it's either a half, root 2 over 2, or root 3 over 2. The easiest way to remember which one goes where is to think about which one of these 3 numbers is the biggest. Right? 3 is bigger than 1 or 2. So that's the biggest one. And 1 is smaller than 2 or 3. So the one that has a 1/2 in it is the smallest one. Now look at this point. Compare this point to the other 2. Is the y value of this point bigger or smaller than the other 2 points? Right, this is the smallest y value. So when you label the point here, you want to put your smallest number on the y, because the y value here is way less than these 2. And then it's also the furthest from the y-axis, right? It's way further to the right than these 2 points. So the x value here is the biggest number. So biggest, smallest. For the 45 point, notice it is exactly in the middle, comparing distances from the y-axis and also distances from the x-axis. So both of those values are the middle ones. And then at 60, that point is the highest, so the y value should be the biggest number. It's also the closest to the x-axis, so the x value should be the smallest number. All right. That's a lot of stuff. Go practice this. And then we'll come back and talk about the back. I'll probably make a part 2 just to split this up a little bit. All right, guys. See you in the next one. Deuces.